Hi, I am Giri Srivastava, and today I am going to discuss about IBM Netezza Data-warehouse Appliance. Before we start with the IBM Netezza Data-warehouse Appliance, let us take our obsession about the Oracle. The Laurie Allison in October 2009, he made a statement like, "If you'd like to take us on, make our day," and his second statement was in 2010, December 2010, you can say, "Our goal is to become a number one high-end server business for both online transaction processing, called as OLTP, and data warehouse, both of these segments." Laurie clearly has IBM in his sights as an overall competitor. This was clear from the statements he made during the Sun acquisition in 2009 and 2010. He is gunning for the high-end server business, apparently for both OLTP and data warehouse, with his weapon of choice called as Exadata. I'm not saying anything about the OLTP, but if we are talking about the data warehouse, then the Oracle doesn't stand a chance with or without Exadata. At Netezza, we are obsessive about the Oracle and beating them on their turf. As a result, we win by 86% against the Oracle, with the Netezza, with or without the Exadata. How we win? We win by this Netezza appliances, the twin appliances and the customers. We win by the true appliances. So before getting into this Netezza, let us talk something about the appliances, what the appliances mean. The appliances, that is a black box solutions, which are commonplace in the IT industry. We all are familiar with how they are having simplified operations and revolutionized entire markets with networking devices or networking appliances. For an example, a networking box like firewall or ASA boxes or CSM boxes, it will give you the functionality to create a multiple number of users or multi-users network in a simple or in their homes in a matter of minutes. The another example of this type of appliances is the iPod. You can see about the iPod, the advantage of the iPod. If we want to listen any kind of music, then we can go for this type of iPod. As compared to PC and systems or laptops, it's a very low cost and very easy to install. So in place of listening our music, we can go for these iPods. The iPod is a greater example of an appliance that are simplified and revolutionized digital entertainment instead of the PC and the laptops. They do only one thing, but it is better than the alternative, which is PC and the systems. This is only a plug and play and simplified interface, which is a true appliances is also telling the same thing. It is our dedicated devices, the optimized for purpose, complete solutions, the fast installation, very easy operations, standard interface, and low cost. So let us discuss something. Why Netezza? Okay, because we are having so many advantages of this Netezza. So let us discuss one by one. The first one is the seamless integration with Informatica, Business Object, SAS and SQL Server packages called as SSIS packages. SAS is nothing about a statistical analysis system. It is having a very little DDL and SQL conversion. They used same table structures, converted primary indexes to distributed columns. What does it mean called as distributed columns? We'll discuss it later on. The 10x and 200x performance improvement in BO reporting, and it is very fast to deploy. Price to performance very appealing. Ease of use for the administrative tasks, for the DBA tasks, and support all type of DB structures. Let us discuss something about the Netezza 1000. Netezza 1000, it's a kind of Netezza data warehouse appliance which will provide you to provide you the functionality to store your data into the racks, or you can say that the different racks are available inside these kind of boxes, where we can store our million or trillions of data at a single time, and these all data are distributed across these all racks or disks, you can say. So the IBM Netezza 1000, formerly named as TwinFin, models include hardware configuration of single rack or multi-rack configuration. As I said, we are having a single rack or multi-rack configuration in Netezza 1000. Within each rack are numerous components that work together to provide asymmetric, massively parallel processing of Netezza architecture. The key hardware components include the following: snippet blades, it is also called as S blades, hosts, and storage arrays. This is three kind of Netezza servers or Netezza boxes, which you can see in the figure. The first is the model number 1003. It's a kind of boxes which are having the number of S blades is 3, 1006 the number of S blades is 6, and 1012 the number of S blades is 12. As let me tell you one thing, in one single S blade the number of snippet blade is 8. So when we talk about in 1003, the number of snippet processors are 3 into 8, that is 24. In 1006, the 6 into 8, the number of snippet processor is 48, and in 1012, the 12 into 8, or you can say that 8 into 12, the number of snippet processor is 96. As like same as disks. Disks in one S blade we are having 8 disks. So 8 into 3 means 1003 we are having number of disks is 24. The 1006 48 and the 1012 96. The data uses, you can store the data, how much data you can store inside this 1003 is 8 TB. In 1006 16 TB, and in 1012 it's 32 TB. Let us discuss something about the S blades, what it will do and how it is configured inside that kind of boxes which we have seen in the previous slide. S blade are intelligent processing nodes that make up the MPP, massive parallel processing engine of the Netezza appliances. Each blade is an independent server that contains a powerful multi-core CPUs, multi-engine FPGAs, and gigabytes of RAM, all working in parallel to deliver a high performance. Each Netezza 1000 chassis can contain up to 12 S blades, which we have seen in the previous slide. The number of S blades are 12 in the model number 1012. The Netezza hosts. The host server is a Linux server that runs the Netezza software and utilities. The host controls and coordinates the activity of the appliance. As I said, this is a Linux server which will behave like a host, and it is used for the security purpose, because you also know that Linux is a very secure. So we can get it as a host inside this Netezza server. It performs a query optimization. This host performs the query optimization, controls tables and database operations, consolidates and returns query results, and monitor the Netezza system components to detect and report problems. The host is highly redundant, highly available server. The Netezza 1000 system have two hosts in a highly available configurations. Each Netezza 1000 system has a keyboard, video, mouse, that is called KVM unit, to give administrators at the Netezza appliance direct access to the host operating system. The storage arrays means where we are going to store our data inside that boxes. Each storage array contains either 2 or 4 disk enclosures depending on the models. The combination of S blade chassis and its storage array is called a snippet processing array, called as SPA, snippet processor arrays. Within each SPA, 2 disks are reserved as spares, which can be brought into service in the event of disk failure, as you have seen in the previous couple of slides, where I have shown you the model of this Netezza 1000 system. You have seen the number of disk blades. In 1003 it was 24, and the 2 was written in the bracket. It was the number of disks which is keep it separate for the backup purpose. Means in case of if any failure is occur inside that boxes, your all data got backup into that disks, and this is brought back again into the service if any data is if any disks are failure. The Netezza 100 boxes. It is similar like Netezza 1000 boxes, but it is generally used for the testing purpose or for the training purpose. You can tell that. The IBM Netezza 100, formerly named as a schema system, is a single chassis, single host based on the Netezza 1000 architecture. Means the architecture of this Netezza 1000 and Netezza 100 both are same. It is the Netezza 100. It is totally totally just based on the Netezza 1000 architecture. It is a data warehouse appliance for querying smaller, non-highly available database environment, as well as for developing and testing applications before deploying them onto the another Netezza systems. As I said, it is generally used for the testing purpose, and you can say that it is used for developing and testing purpose and before to deploy your application into the Netezza systems. The Netezza 100 chassis is a rack mountable in any standard data center rack. You can connect and manage the Netezza 100 over remote network connections, just as you can for the Netezza systems. In the figure you can see that we are having the number of S-blade is 1, only 1 in the 101 model. The snippet processor is 8 and the disks are 8 and total data storage 2.8. Because this is a simple test based machine, or you can say that it is used for the testing purpose, so there is no need to having a huge amount of data storage capacity. The Netezza 100 system operates similarly to other Netezza systems. They have an S-blade and a storage array to run queries and store your database and the table. You can use the same ng command to manage them as well as to perform tasks such as database backups, since the Netezza 101 is a non-highly available system. You do not use any clustering and heartbeat commands to manage it. Heartbeat command in the sense it is not required to write complex commands to install this Netezza 100 system, or it is not mandatory to run a heartbeat command or very lengthy or complex commands into this. You can run the same SQL queries on the Netezza 100 system as on Netezza 1000 system. Means you can say that the performance and the functionality is same for both Netezza 100 and the Netezza 1000 systems. Let us talk about the technology. What kind of technology this Netezza boxes can handle, and what is the technology is behind this Netezza system. The Netezza appliances use a proprietary asymmetric massive parallel processing called as AMPP architecture that combines open blade based on base servers and disk storage with the proprietary data filtering process using field programmable gate arrays FPGAs. Netezza proprietary AMPP architecture is a two-tiered system designed to quickly handle very large queries from multiple users. The first tier will handle the high performance of SMP host that compiles data query tasks received from the business intelligence applications and generates query execution plans. It then divides a query into a sequence of subtasks or snippets that can be executed in parallel and distributes the snippet to the second tier for execution. And the second tier consists of multiple number of snippet processing S-blades where all primary processing works of appliance is executed. So the total idea behind in this technology is the Netezza appliance follows the asymmetric massive parallel processing architecture, which will provide the two-tier system design for quickly handled and very large query for the multiple users. From the two-tier, the first tier of this highly performance Linux SMP host, which compiles the data query and which is text from the business intelligence applications and generate the query execution plans. This is the work for first tier. And after generating the execution plans, it will divide into two sequence of subtasks or multiple number of subtasks or the snippets that can execute it in parallel, and it distributes the snippet to the second tier for the execution. Means in the first tier it will receive the query and it will divide it into different processes or different tasks, or you can say that the subtask, and it will send to it into the second tier for the execution purpose. The second tier will receive it for this multiple number of tasks or multiple number of snippet processing and send across the different blades for the execution purpose, where all the primary processing works of appliances will be executed. The S-blade are intelligent processing nodes that makes up the massive parallel processing engine of the appliance. Each S-blade is an independent server that contains multi-core Intel-based CPUs and it is a proprietary multiple engine high throughput FPGAs. Let us talk something about the traditional data warehouse complexity. In this figure, you can see that how data are complex across the server. When we supposed to add something inside the database server, or we want to talk or we want to communicate with the database, it seems. You can see in the figure how we are requesting for any kind of data from the database and how it is retrieving the data from there. The complexity is very high, very high. Suppose if we want to communicate with the 100 user and trying to retrieve the multiple or millions or trillions of data from the data warehouse, at that time what will happen? Definitely the traffic will be too much high. So we are simplifying our full architecture with this Netezza data warehousing appliances. So what it will do is the complexity of the data will gone. It is very less. Let us talk something about the appliance simplicity. Loading the Netezza appliance, the data integration called as ab initio, business object, SAP, composite software, expressor software, the Golden Gate software, Informatica, IBM information servers, Synopsys called as from Oracle, Wisdom Force. This all things can be handled with this Netezza data warehouse appliance using SQL, ODBC, GDBC, OLEDB. When we talk about the data out, means for the querying purpose, we can retrieve the data from the database appliance, this Netezza data warehouse appliance, using the Acticute, the business object, Cognos, information builders, Calido, Kaizen, so many tools. Means that the meaning is if we want to retrieve the data from the data warehouse appliance called as Netezza, directly we can retrieve the data from there. It's a very simple to retrieve. Let us talk something about the appliance architecture. In the figure, it is clearly mentioned that the Netezza AMPP architecture, asymmetric massive parallel processing architecture. You can see here in the figure the Netezza appliances, we are having multiple number of disk enclosures and we are having multiple number of S-blades which is connected through the host with the network fabric. And finally we are having the application. So whenever we supposed to retrieve the data with the application will communicate with the host. Host will go to the S-blade, and S-blade is having the capacity to retrieve the data from the disk enclosures. And as I discussed earlier also, we are having the two-tier the system over here inside the AMPP architecture. One is called as a S-blade and one is called as a retrieving the data for the execution. So you can see here, suppose if we have created or if we have listed out the SQL queries as select district product GRP sum max from monthly RX and whatever, where month equals something and the market equals something and the specify is the something. So if we process this, if we want to process this query into our this FPGA, then what will happen? Just have a look on this figure, you can clearly understand. So first the query is dividing into different parts as it does the first tier, and in the second tier what it will do is it will send for the execution, and in the second tier what will happen is it will do its task and finally it will give you the output as it is doing in the final stage. The IBM Netezza twin architecture, you can see here in the figure we are having a box, or you can say that it is look like a CPU. It's a kind of box that only, where we are having multiple racks enclosed over here. This is optimized hardware plus software. The purpose built for high performance analytics required no tuning. True MPP, the all processor fully utilized for maximum speed and efficiency. And in the right side you can see the green boxes, it's called of streaming the data, hardware based query acceleration for beating fast results. Deep analytics, complex analytics executed in database for deeper insights. This is a Netezza S-blade. The green S-blade having multiple number of RAMs enclosed here. The components of these S-blades are the modules, which is also called as a SAS expander, then DRAM, then Intel quad-core processors, SAS expander as a model, the dual-core FPGAs, this is the Netezza DB accelerators, and the IBM Blade Center servers. I was talking about the failovers. So in case of failovers, what will happen is, if any disk is got failured, then the data which is present inside that disk is got transferred, automatically transferred to the running disks. So you can say that we are having the three partitions of this kind of disk. One is primary, another one is mirror, and the last one temp. So all user data and temp space mirrored, and disk failures transparent to the queries and the transactions. Failed drivers automatically rearranged, bad sectors automatically rewritten or reallocated. As in this figure you can see, if any disk is got failured, then how these disks are overridden or written into the running disks. The drivers automatically reassigned to active S-blades within a chassis. Read-only queries automatically restarted. Transaction and loads interrupted. Loads automatically restarted from last successful checkpoints. You can see here this red box or red disks are failured. So what is happening is the disks are automatically rearranged in the running disks. This is the TwinFin 24 specifications. 16 which is 8 into 2 disk enclosures, 192 means 96 into 2 1 TB SAS drivers, 8 hot spares, red one mirroring. This is the latest one which we are supposed to use. The capacity of this kind of boxes are 250 TB, data scan speed is 290 TB per hour, and load speed is 2.0 TB per hour. Power rack is 7400 watts and cooling rack is 25,500 BTU per hour. This is the specification which we got in Net 2012 specifications. I hope you got a clear idea about how this Netezza twin machines are work and how we are going to work with it, how we are going to store this data and why we are going to use this one. Let us have some discussion for this installation part of this Netezza twin appliances and how we can work in it. So before starting with that, let me tell you one thing. For the testing purpose, as I have already told you that as the testing purpose we can use the Netezza 100, but instead of Netezza 100 machines, we are having a Netezza emulator for the testing purpose, which will give you the illusion of this full Netezza 24 specification if it permits for your system. So let us try to install that in our system. To install Netezza Appliance or Netezza emulator in our system, we required one VM VIX file. So let's go ahead and install a VIX file for Windows 64-bit. So for that purpose, we will store this VIX file into our system. The VMX VMware VIX file. As I told, it will take some time, so it's finished. So then we have to start with the Netezza Appliance. So let's install IBM emulator 6.0.8 for Windows 64-bit. So we are installing it. It will take some time. It's started now. Now we are in the process of installing this emulator. So we'll go for the default configuration. You can see here it is installing that host.vmdk file. As I said, it is installing the Linux server as a host inside this IBM. It is almost done, so most probably it will complete in a couple of seconds. Now it is installing the Netezza simulator link and the spools. It's done, so we can press finish and it will generate one IBM controller. So you can double click on that. It will start its server and the spools. You can see the IBM Netezza software emulator for developers version 6.0. You can see here the host VM is stopped and the spoo VM is stopped. So we'll click on this start. So you can check here, it is showing that the starting host, checking host VM configuration. So after checking it, automatically it will show you that host is started and the spoo VM is also started. Host powered on, waiting for system startup. give some seconds to start it. So you can see here it is discovering, it's running, everything is working fine. VMware tools started, host network stack started, host started, starting spoo, checking, and the solve. Spoo is started, waiting for NPS subsystem started, NPS subsystem stopped and starting. So it is telling that it's initializing. Once it will get it done, it will tell you that you are online. It is going for pre-online, then resuming, and then online. So you are complete. Now we'll start with our putty. We'll put this IP address into it, 192.168.196.130, and then we'll try to save it. Better to save it, this one. Load or open it. Now it will ask about the login ID and password. Give a login as ng, and once it will ask for password, then give ng as password also. Now it is asking for password, so let's give the password as well, ng. Let's see whether it is correct or not. Once again it is asking for passwords. I think I have given some wrong. So now ng is username and password, so we have connected with this ng. Now let us talk something about the Netezza database systems as well. How we are going to handle the Netezza database inside this Netezza Appliance. So it is telling that accessing Netezza SQL using ng-SQL. It is telling that once you are open with that ng user ID and password, you can use the ng-SQL command for Netezza Data-warehouse Appliance, or you can say that inside the system or from the Unix client system that can access the Netezza host. The command uses the client-server model, which includes a server that manages database files, accepts connection to the database from client applications, and performs action on the database on behalf of the client. The client application that can perform a variety of database operations. The client could be one of many tools and is often created by the users. Let's go to that prompt and let's check whether this ng-SQL command, what it is doing. ng-SQL. So it is telling that welcome to ng-SQL, the IBM Netezza SQL interactive terminal. Press /h for the help with the SQL commands. Press /word symbol for help of the internal slashes commands. /g for terminate with a semicolon to execute query, and /q for quit. Then this is a system and admin, so you can press here /h for any kind of help. So it will tell you these are the help is available over here to create tables, to delete tables, to create, alter, modify, views. Everything is present over here. So you can take the help of this for the creating of tables. You can create the users, you can create the external files, you can create the different databases over here. So different users with which is associated with different databases. After invoking the SQL command, the prompt contains the name of the database and the username. In the following example, which we have seen inside our prompt also, it was a system and admin. By default, the Netezza system uses uppercase letters to display SQL output. The system case can be configured to use the lowercase instead, which was default in earlier Netezza releases, but now in the latest one it is in uppercase. To connect to the database with existing, the ngSQL command use the /c option. /c, which is nothing but a connect, then database name, and then the password. For an example, if we are having a sales database with the user Millie and the password blue, then it will be connected with a /c command. You can see here in the slide. And the /set command will provide you the functionality to check what kind of release version you are using, and what is the hist size and what is the DB name. So let us go and create some database over here, or it will be better if you create a table over here only. So let us try to connect with this Netezza system and try to execute some command. As I told you, all data are distributed across all the CPUs. So let us create one table and check out whether all the data are distributing across all the SPUs or not. Let us connect first with the system. So for that we will write ngSQL. So it will get connected with the admin. Now let us create one table. Create table table 1 having some values called as id and name is varchar and having some value 20. Distribute on ID. Sorry, it is getting stuck, and the ID it is trace. So it is telling that table has been created with the distribution. So we are giving the distribute on, means we are trying to distribute our table data across the SPUs. Okay, we are trying to distribute it, whatever the data. Suppose we are having a multiple number of data, millions or trillions of data is present inside this table. So all the equal data or nearly equal data can be distributed all across the SPUs. So let us insert some more data inside this. Insert into table name values is having as I said, this is not enforced with the primary key and foreign key constants, so you can insert the duplicate keys. So I'm trying to insert some values over here, and as I said, it will store this all data and distribute across all the SPUs the nearly equals data or mostly equals data. You can see all the data. This all data are inserted over here, and as I said, it is not enforced with the primary key and secondary key, as we can create the primary key and foreign key constants over here, but it is not enforced with that. Now let us check how it is distributed across all the SPUs. So for that purpose we'll write select id comma name comma data slice id from the table name. So it will show you the nearly equals data or equal data are distributed across this same spool. The 1 is stored in the spool number 4. The 112 are stored in spool number 1, and the 110 is stored in spool number 3. This is how the data are stored inside this Netezza all across the spools and distributed across them. This is all about Netezza Data Warehouse Appliance. I hope you have enjoyed this video and got some knowledge on Netezza Data Warehouse Appliance. Thanks a lot for your attention, and please feel free to mail me for any query on girish092.ch@gmail.com.